Hello and thank you everyone. My name's Mark Thompson and I'm the founder and managing director of Talga Group. We're an ASX listed company that we also trade over the counter in the USA and in Germany. And we are building a anode production project in Sweden and for supply of the lithium-ion batteries in Europe. So people have been talking about EVs affecting battery demand for a while, but for now you actually have serious, data coming in from sales. Penetration rates of EVs, particularly in Europe, but spreading around the world, are shooting up. So it's no surprise that this is providing the data for a lot more interest now in the battery supply chain for all these electric vehicles. And more recently, we've seen announcements by large auto companies and OEMs that are stopping either the design and engineering or even the production of their internal combustion engines. So you have targets for internal combustion engines not to be built by certain points. And of course, this even today, this slide is actually superseded with Ford's more recent announcements. So it's being actually conducted by industry themselves, are actually decreasing the internal combustion engines. And overall, this means you have a huge amount of demand for batteries now rocketing up over the next 9 years. There's a requirement for nearly 4 million tonnes of anode now from a global production, which is probably only in the range of 200 to 400,000 tonnes at the moment. So demand is growing really fast. And the point of this slide is to point out that of all the minerals that make up the battery, particularly the active parts of the battery, graphite is actually one of the largest single components. It makes up the anode, which is the negative side of the battery, and that electrode is right now heavily concentrated in production from China. So while everyone often is focusing on nickel, cobalt, and of course lithium, the other side of the battery, not the cathode but on the anode, no one's really been paying a lot of attention to until recently. And we are, of course, located in Sweden, which is very close to a huge amount of battery production capacity that's being built. This is some recent work by Roland Zen from Pareto showing this. Only just wasn't that many years ago, there was 2 or 3 battery factories planned for Europe, and now it's really huge. Total demand by the end of this decade is up around 600 gigawatt hours. So you're looking at, approximately 1/5 of the near-term production globally being built, but the rate of production is massive compared to the rest of the world because it has to be built very quickly. It's happening there very fast. So the EU is a fantastic market, and predominantly because the governments themselves are supporting this move. So you now have internal combustion engine vehicles being phased out or banned by different countries at different times. And this is spreading around the world, I believe, but Europe has been very proactive in this space. In addition, Europe is introducing what's called the battery passport. It's a legislated, essentially, barrier where imported materials for batteries will have to be assessed for their life cycle emissions. And if they do not meet muster, there will be tariffs and taxes imposed. So you're currently looking at a 100% imported supply chain is going to be filtered to help support local development, to be more robust strategically and economically for Europe, and additionally, of course, for the UK as well, post-Brexit, where they're very busy also looking at developing massive electrification of their transport industries. So the opportunity is quite simple, to be honest, for Talga. It is to become the world's largest and most sustainable and lowest cost producer of anodes for lithium-ion batteries. The opportunity is to focus on the graphite side of the battery, where, to be honest, the supply chain is not only extremely concentrated in Asia, the knowledge of how to make the materials and the complexity around that does not exist very much outside Asia. So unlike the cathode, which contains all the nickel and copper and other things that trade on the LME or have some sort of price visibility, anodes made from graphite, very poorly understood, and there is a great opportunity to be therefore a very large and significant producer. In fact, we have aims to be the largest outside China over time. The ideal is to build this on 100% renewable electricity, which we have in Sweden with the hydroelectric plants. And of course, we are very close to all of these battery plants. We are only 1 hour actually from the closest one, which is Northvolt. We are not far away from the plans for Freya's plants in Norway. And of course, we have direct road and rail access into the rest of mainland Europe. So we can actually take material from our site in Sweden directly down into customers in Germany. Quick word on the group then. So we are based in Sweden. We're an Australian listed company. That's where we started the company, but most of our staff and operations are all in Europe. And we've been actually working on this for a few years now. We're targeting full-scale production in 23, but we've actually been working for several years now with auto OEMs. We have a large amount of work contracted with various battery manufacturers and some auto OEMs, qualifying the material to go into batteries, which you can see on the right here. You can see a piece of our raw graphite ore, but you can also see some of our anode material in some batteries. We have a pilot plant and to make material down in central Germany in Rudolstadt. We have a lab facility, a product and technology centre in Cambridge in the UK. And our main anode production over time, of course, is shifting up to Sweden. That's where we have our mines. So it's basically resources in Sweden, current metallurgical processing development in Germany, and product development technology in the UK, with the ability to expand those operations and essentially be a fully vertically integrated developer across Europe. So we have the mine, we have the mineral processing, we have purification technology and coating technology to produce what is a fully under control from mine to customer product. So we actually produce a coated anode, what the equivalent would be of a large chemical company like a Mitsubishi or a Hitachi or a POSCO, for example. So our customers are not necessarily trading companies. They also include the direct lines with the customers and the auto OEMs. And how can we do this? It's because we have in-house expertise. We have got people that know industry, that have worked for battery companies. In fact, Dr. Capiglia, who's chief of our battery technologies, he's based in Osaka. Other staff have got extensive backgrounds in technology IP, but also commercial aspects with a lot of our customers, actually. And this is not that easy to do, to be honest. So it's not like every graphite company that says it's going to go downstream makes what is technically coated anode ready to be used by a battery manufacturer. It's quite common to do various steps of purification and shaping and so forth, but at that point the material is still graphite. It's not actually an anode, and it has to then be further treated and coated to be ready to form a slurry to go onto a current collector. So this is what Talga does. We actually have a finished product. And in this way, as I mentioned earlier, by having highly engineered products, and they're quite differentiated from others, we step out of the realm of graphite miners and processors into advanced materials in chemical companies. So we sit alongside most of the high quality Asian material providers. And as I mentioned earlier, and if you look to the right of this slide, you can see some of the companies that we interact with directly. So what are we building initially? Well, we're building about just under 20,000 tonnes of coated anode. We've done a pre-feasibility study that shows a 22-year mine life. It's got very strong returns. CapEx is about $200 million US roughly, but it's got an NPV of just over $1 billion, IRR of 55%. And this will basically spit out about $180 million US of revenue for 22 years. And it's in a great jurisdiction, obviously in Sweden. It's got a very, very clean footprint. Already we've got expressions of interest for far more than this, in fact 3 times that, and we'll be updating that number soon to the market. But right now, yeah, we've already had to do a scoping study on a 5 times expansion that would take our total production in the second half of the decade to over 100,000 tonnes. So to convert that into battery terms, that's roughly 20 gigawatt hours of anode in the initial phase, but already that's superseded, and we're making plans for upgrading that to over 100 gigawatt hours, and it's looking likely there'll be further increases again in the short term. We make multiple products of anode, so we have mainly a graphite anode, but we also have a silicon-rich anode as well, which is starting to come in as a higher energy product, and we also have super fast charge material, and we also, with the Faraday Institute, we've got many programs running on some of these products, but including a solid state product as well. So this would be a very commercial, very practical way of making anodes for solid state batteries as well, like have been the the hot topic recently over in the States. So anyway, we're basically built for large volume, high quality material that's currently used by battery factories now, but we also have a whole range of next generation products that can slot in as the technologies change, and we can convert over to take advantage of all of these as well. So we're extremely robust for the long term. The deposits are based on graphite ore bodies that are grade about 25% carbon, and so that puts them as number one in the world actually of JORC or NI 43101 resources for grade. They're also very extensive. We have literally tens of kilometres of strike, and they extend very deep into the earth. We've only just scratched the surface of how big they can be, but they don't cost much to get at and to develop, and we have permitting underway for that expansion. Critically for our customers, we have super low CO2 emissions, even far lower than the EU average, and very, very, of course, much lower than anything in Asia out of US. And because of our super high grades and our super high yields, we have industry leading yields that are in fact nearly an order of magnitude above most mines in the amount of anode per tonne we produce per tonne of resource. We also have very low costs. We are actually competitive with China for cost. So this is a high quality European jurisdiction with a high quality technology product, completely owned all the way through the production of it, and it's actually got competitive costs. So this looks a bit strange. It's a really unique asset. It's got very special properties that allow this to happen, and we've been proving this over the years with various trial mines and prototype developments. We've previously mentioned currently we have MOUs with Mitsui and LKAB, who are looking at entering into the project under joint ventures and other ways to look at developing the project as partners. But we also have a whole range of downstream partners working with us on battery anode materials, conductive additives, I guess things we can't necessarily talk about, but graphene-based materials that for lightweight or increasing conductivity, ranging from Bosch to Bentley to JLR, and even packaging and cardboard with billet causes. So you have a very unique source of graphitic carbon that's predominantly doing battery and energy related materials with its special properties, but it also allows it to be used for things such as with the graphene materials as well, which we've got extensive knowledge of now. So looking ahead, it's going to be a big year for Talga in 21. We have major discussions and key touchstones and milestones on funding for the project, and working through this with our partners, both known and the things that we're working out behind the scenes. We have got feasibility studies on adding production by looking at expanding into the UK and having anode refineries there. We have a major DFS of the previous announced PFS that will be due at the end of next month. And we also have got the capacity to produce up to about 5,000 tonnes of anode permitted at the moment that we'd like to start putting into production this year. Probably the biggest thing we're doing is battery anodes have to be tested not through purity and specs alone, but by testing in batteries. So they've been getting tested by our customers in batteries at different sizes, and they need more. They need bigger tons, and they need to see the material coming off contiguous production lines. So we're building what's called an EVA plant. We just completed a combined institutional placement and shareholder SPP totaling $55 million Australian, and that's just been completed a few weeks ago, and that's going to allow us to actually construct a continuous plant of qualified anode materials in Sweden, and that's already underway. We're starting to actually order items for that, and we intend having that up and running this year. And we're also going to conduct some big drill programs to increase resource scale to underwrite what we think will be major expansions in future. The share price of the company's done quite well over the last 12 months. We have a market capitalisation of about $450 million right now. We have only 300 million shares on issue, very few options, and we have a cash balance. So you could say pro forma, I guess, at the end of the month of around $60 million. I have skin in the game. I'm the largest shareholder currently, and other institutional shareholders, both in Australia and internationally, are amongst our top 20 of what is just over 10,000 shareholders now. And with that, I would invite you to, we will of course upload a copy of this presentation, and in the back of it there will be an appendix with Gantt charts, timelines, and also details of our PFS studies, Also details of the scoping study that we did on the expansion project called Niska, which will take us up to being the largest anode producer outside China. And of course our resources, which are the largest in Europe as well as the highest grade technically defined in the world. Thank you very much. Look forward to catching up with you later. Bye.